What is up, everybody? Welcome to the Ham Radio Crash Course. How's it going? Welcome to Friday. Welcome to It's 5 o'clock somewhere. It's 5 o'clock right now in California. Thank you for joining me. Again, we're trying to breed inclusivity in radio, and that's what we're doing here with the Ham Radio Crash Course. So thank you for joining us. If you can, check out our links there in the Discord. Oh, yeah, is it Friday? Oh, it's Saturday, isn't it? I'm so used to Friday. Excuse me, Saturday, 5 p.m. Check us out on Facebook and Discord. And yeah, we got a fun show today. We're going to be talking about demystifying repeaters, specifically how do you build them, maintain them, and doing all that fun stuff. I've got Hayden Honeywell with me. We'll be talking to him shortly. Paul Mumbley says, actually, it's Sunday here in NZ. That's right. Yeah. All right. Getting my sip in here before we switch over. Yeah, I got some new memes. If you want to submit memes to me, just join the Discord and shoot one over to me on the memes chat. All right, let's switch over. Anyway, thanks so much for joining us. Like I said, big show. Really quickly, we are doing the Discord after chat, so if you are interested in that, please take the link in the description, and you can join our Discord. Last week, we had 72 people all on at one time, and it was awesome. So that was a lot of fun. I'm glad everybody could do that. And we've got the Patreon still going on for the $1 newsletter, so if you're interested in that, go ahead and join over there. Real quick, we still have the contest going for the G90. Once we get to 73,000 subscribers, we're going to go ahead and fire that off and give that away. We'll do a live stream, and we'll have some giveaways like some Abri antennas. And I'm doing the Soda Overnighter right now is scheduled for November 9th is the day that we're going to be going out there. So if anyone is interested, you can still email me on hashnasi@gmail.com or Instagram or Discord or wherever. Let me know you'd be interested, and you just meet me and we'll go, because I'll be there. We'll just be hiking. So very cool. I got one thing I want to talk about, and this happens to the best of us, and I wanted to just put it out there, and I'm going to put somebody on blast right now, and I don't even care. So I got this comment today from Will Rogers. Sorry, Will. How can I get your no-code dumb bleep videos off my suggested playlist? Lid. People don't know what lids are. Lids are people who jam repeaters or are just basically poor operators, and you don't know half of what you think you do. So I get comments just like everybody does. I know a lot of people, they go to a club and they deal with people that aren't the nicest to them, and so it happens to all of us. It happens to me as well, but something like this doesn't bother me, because all I do is I go over to our Facebook page and I just look at all the people that are passing their licenses. Pass my license, pass my license, pass my license. Corgi, Ethan's Corgi, cute dog. There's another one. Got my license, amateur general, passed tech general and extra tonight. Aced the tech exam this morning. So don't worry about people giving you crap. There's a community out there for you. Don't worry about the naysayers and all the negativity, because you shouldn't let that stop you up, right? So I do have Hayden with me. Hayden is VK7HH, and he is Ham Radio DX. The link is in the description on the YouTube here. I'm going to bring him right over because we've got some news out of Australia. So how you doing, Hayden?
Yeah, good. Thanks, Josh. How are you?
Very good. Thanks for joining us. So, go ahead.
Say,
yeah.
Will who? Sorry, Will making comments like that. We get that here in Australia too, so don't worry about it.
Oh yeah, absolutely.
Yeah.
So, had some news come out. Let's crank. Oh, your volume's low. Sorry about that. Crank that up. Okay, good. So, we had some news come out on Kenwood, and you pulled it up really quickly, and you knew some things about it. So, tell us what's going on.
So I heard this about middle of last week. Now, the title of the news article is "The End of an Era in Australia," and the news report says we can report that after 25 years that Kenwood Australia will no longer be importing amateur radio products into Australia. High import charges, low margins and poor sales are the reasons being given for this decision by Kenwood Australia. So I think that just summarises to say that you will no longer be able to buy Kenwood in Australia, but you'll still be able to purchase from overseas.
And that's going to put a big cost upper, right? Particularly for HF radios.
Yeah, and potentially to warranties, having to return it overseas as well.
I didn't even think about that, but yeah, we were talking before the video, and that was, you're like, warranties could be a big problem. And yeah, so you're either going to have to go to like a third party that's going to have to source their parts from somewhere, right? Or ship it away, which seems like a problem.
Yeah, yeah. And there's quite a few Kenwood owners in Australia. I know a lot of people that have got the TS2000s, the handhelds as well. So they could potentially be affected. But yeah, it's a bit of a shame after 25 years. It's a long time.
Indeed, yeah. So we've got you out here today. You are a repeater builder. You built repeaters on your own privately. You've built repeaters with a club. You may have a YouTube channel. Why don't you just go ahead and go through a little bit about your background, what made you want to start Ham Radio DX, and kind of what you're all about?
Yeah, well, so I've been licensed about 15 years. And when I first got my license, one of the things that I noticed where I lived was I had very poor repeater coverage. I live in a valley, so there was no nearby repeaters. The nearest city is about 50 kilometers away. So at the time I thought, I might build one myself and look into it. And eventually I got parts together, got bits and pieces here, and I cobbled something together and had it running. And there was a few other people who lived nearby. They used it as well. And then it moved from there, where I had it sort of in the valley, to on top of a mountain, which covered a wider area. And then others started using it, and then it just flowed on from there. So
you've been active in this for a while now, it sounds.
Yeah, so it was just after I got licensed, I got interested in FM repeaters. And as far as the YouTube's concerned, that's a very recent one, Ham Radio DX. So there's a lot of videos that I've been interested in. So a lot of technical related videos are on there. So only been doing that for about 4 months, and it's been going well.
So you just gave away a rig pie. How did you play around with it at all?
I played around with it. I've got an FT991, and the rig pie was great on that. You could control it, audio, transmit, and you could be on the other side of the world and still using your radio. I also have a remote rig as well, which is where's that from? It's from Europe somewhere, the developer, and that controls an FT857. So I've got a remote station, which is located on a mountaintop as well, and that's my primary remote setup. But the rig pie, it works really well, and Lucky Ham in North Dakota won that.
Yeah, so we were just talking about shipping. You had to ship something from Australia to the States, and North Dakota is one of the harder states to ship stuff into, from what I understand.
Yeah, it wasn't that expensive. It was pretty good. It surprised me anyway. I don't know how long it'll take to get to him, but I hope to hear from him soon.
I like it.
Usually it's importing into Australia is really, really slow. As soon as it reaches our shores, it's really slow.
I bet. Yeah. So this Kenwood thing's going to be a problem for that too. I hope that's not the way things go from here on out. But I've heard shipping things into Australia or just getting stuff like video games and stuff is really difficult in Australia too, right? Cost-wise, the whole 9 yards.
Yeah, and we've got taxes and things like that as well, import charges that have just recently come about. So
yeah, I believe it. Okay, so you put some slides together, which I love when people do that, because that means I don't have to. But you've got a wealth of knowledge with some pictures packed into this bad boy. So I'll do the flipping. Do you want me to? Do you have anything to say before we start this off?
No. Well, you said about introductions. That's mainly on the next slide anyway. So
okay.
Right, I'm just doing that.
Oop.
So
there we go. There we go. One of these days we'll figure this out.
There we go. So here in Australia we have 3 license classes. We've got Foundation, which would be your technician, I think. That's the first one.
Yep.
Standard, which is general, and Advanced, which is the equivalent of extra. I got my Advanced in I just saw that chat.
Yeah, thank you, Lee. Thank you.
I got my Advance in 2010. First repeater was 2007, so a couple of years after I first got licensed. and I've built repeaters on 10 meters, 6 meters, 2 meters, and 70 centimeters. Started my channel, Ham Radio DX, in about May 2019, and you can find me on Facebook, Instagram, Twitter. I've got a blog which I occasionally post to as well.
Yeah, that's what it feels like at running a blog and a YouTube channel and everything else.
Trying to post it everywhere, and I've got an email address if anyone wants to hit me up with any questions.
Excellent. Very good. Okay. All right. So one thing I just want to throw this out there as we get things going. So most of the people watching this are all kind of like repeater users, and hopefully we've kind of demystified using a repeater. But having a Hayden out here, make sure you post questions that you have about setting up repeaters, running a repeater, maintenance on a repeater, all that stuff, because that's kind of what he's going to be able to talk to us about. And I think that's going to be really helpful. So without further ado, let's go to the next one.
So what is a repeater? So we can see in the first photo, you stand there, you've got your HT, you talk to a base, or you talk to a repeater directly, or that's located on top of a mountain. On the other side of the mountain, there might be a mobile, there could be another user. So that's the basics of it. A repeater is basically an automatically controlled transmitter and receiver that can transmit and receive simultaneously. Mm-hmm. So, as I said, they're located on high mountaintops, tall towers, buildings. They're equipped with high gain antennas, efficient antennas, low loss feed line, and the transmitters and receivers that they use are durable, and they are supposed to last a long time. And they have to be immune to interference, because, I mean, a lot of these things are up on communication sites.
Right, you're packed with other stations, right? You're just got stations everywhere.
Yeah, that's exactly right. So you've got to be mindful of that too. So I guess one way to explain it is it's a little bit like a telephone, a repeater. It operates in full duplex, where so we can talk to one another. I can hear you, you can hear me at the same time. Yep. So because the repeater listens and speaks at the same time, then it operates in a full duplex mode as such. So
the duplexer is kind of like the black magic of repeaters, right?
That's where all the fun happens, and I've got a slide later on a little bit on the theory and how that happens and how that works. So we've got the block diagram there. It's fairly simple when you break it down, really. Mm-hmm. If we start from the antenna, signal comes in, goes into the duplexer. It then goes into the receiver through the receive input of the coax line. Out of the receiver comes the audio, as if you turn up your speaker and you listen to your radio. It goes into a controller, which then controls timeout timers, controls identification, CW ident or voice ident, and then the transmit audio goes back into the transmitter, back through the RF into the duplexer, and out the antenna at the same time. So that's basically a very, very simple block diagram of a repeater.
Right on. And we've got questions coming in, and thank you guys for posting them, because that's going to be, we're going to use those in a little bit. But one question, you mentioned timeout timers, and most of us has probably had to deal with a timeout timer. Why do we need them? If you can explain that quickly. So
one of the things with timeout timers, we need them for regulation. So here in Australia, our regulator is the ACMA, same as the FCC. And what they do is they impose a limit that if the repeater locks up and keeps transmitting for some reason, it needs to have an ability to switch itself off, which is what a timeout timer does. After a certain amount of time, it will then drop the transmitter of the repeater to avoid any interference potentially.
So that's not necessarily because the hardware's got to cool off or it can't handle it. It's an imposed, usually, rule by whatever governing body you have in radio.
Pretty much. So the repeaters that I built are built for continuous duty cycles. So you can transmit 24/7 all day and it won't hurt the repeater. So ideally, if you're building one, that's the equipment you want to use. I have seen some people build them out of handhelds, build them out of mobile radios, and they're just not up to the job. They heat up and they eventually break down.
We should talk about that towards the end. I want to hear your thoughts on that a little bit more. But let's go to the next slide, because I love that topic, because the Baofeng repeater, right? Everybody's heard about that. Yeah. Yep.
Cool. Yes. Okay. So this is a photo of one of the repeaters that I've built. The model of the radio is not important. It's just an Australian model, but the components are essentially the same across many different models or whatever you're building. So if you start on the left, that's the receiver. So the receiver, as I said in the previous block diagram, it receives the incoming signal. The receiver has to be very sensitive and also has to be selective because of being on top of a mountain, as we said, with other comm sites. You need to be able to select the signal that you want to hear. You don't want to listen to all the interference that's going on. So you can see there's sort of I don't know if you can see, there's in that photo where the receiver is, there's those little those cans, the silvery cans on the left hand side. No, a bit further. Yeah, those there. Yeah. So
Okay.
that's the receiver front end bandpass filters.
Oh, yeah.
So what that will do is when a signal comes in, generally the idea is that it will pass the signal that you want on the frequency that you want, and it will reject others. It's not perfect, but it's a start anyway.
Right. And you need a ridiculous amount of filtering, right? Because you don't want anything but that tiny little bandwidth slice of the mode of your operation, right?
True. It depends on where you install it. Sometimes, for instance, I've got another repeater which is installed away from other transmitters, and you can get away with not having like the perfect duplexer if the one exists. But in general terms, that's exactly what you want.
Okay. And so, go ahead if you have something else on this slide. Otherwise, I'll ask you a question.
Oh, I was going to go into the other bits of the.
Oh yeah, that's right. Go ahead.
Repeater. So the controller, that's basically the brain, as I said, timeout, identification, switches the transmitter on, switches it off, the PTT, and things like that. And then, of course, we've got the transmitter, which usually consists of two components: the exciter, which is a lower power that receives the audio in from the controller, modulates it, and then the power amplifier just boosts the signal, boosts it up to higher power.
And generally, how much power are these putting out?
Mine are running about 50 watts.
Okay.
In Australia, our FM, the FM power limit that we have is 120 watts. But
Okay.
Generally, 50 watts is a good balance because a lot of mobile radios are 50 watts
Mm-hmm.
maximum. So you sort of have a good balance then of not too much power. So.
And would you say generally 50 watts is fine for VHF, UHF, since you're up on the top of a mountain or some kind of high structure and you've got an antenna that's kind of designed for what your application is. So you don't need much more than that. Would you say that's true?
Yeah, and it starts to get complicated if you start to, get higher power. You need a bigger power supply. Excuse me. You need a bigger power supply and just things like that. So the units that I use, they produce 50 watts. So that's just what I run them at. So it's convenient, really.
So a good thing to keep in mind is you are running these in remote locations. Power is sometimes at a premium, or you got to pay for it. So, like you said, if you go for higher power, you need more power supply, more equipment, whatever. So, generally, keeping it on the lower side is still going to be effective for your kind of propagation space you're looking for. Would that kind of be true?
Yeah, that's exactly right. So the other thing too is if anyone's using a handheld, they're only 5 watts. So if you're using a handheld in a location and the repeater's using, say, 100 watts, then that's a lot more power, and you can hear the repeater, but you can't get back into it, and you sort of wonder, well, why not? I can hear it full strength, but you're only using 5 watts or even less sometimes.
Yeah, so that definitely happens to everybody. It definitely happens in Southern California. If we've got some really nice mountains where you can pull in a lot of signals that are transmitting down to us, kind of. But getting up there for some people, particularly if you're on like a rubber ducky, right? They might not be able to make it.
Yeah, that's right.
Oh man, George Jones passed my general using your videos and took delivery of a TS480 SAT. Good call. For my first HF rig. Thanks for all you're doing to keep the hobby alive. KC1LQA. Thank you, George. I appreciate that. Sorry. I just want to say thank you there.
That's all right.
All right.
Do that. No problem.
So, you want me to jump slides, or did you want to say anything else on this one?
No, I think that's it. The next one's going to take a bit of time. This is
here we go.
Black magic happens.
All right.
So, duplexes. So, I guess So this is probably the most critical part of the entire repeater system. So what it does is it isolates the incoming receive signal with the outgoing transmit signal and vice versa. So you can see that these ones are quite big. These ones are designed for VHF for 2 meters. UHF 70 centimeters are smaller. But yeah, they're a series of tuned cavities, and as I said, their job is to split, transmit, and receive. They also have a second job too, and that's isolating from other transmitters that are on the site, so to avoid interference. And there's 2 key factors to these, and that's loss and isolation. So they're the 2 main sort of specifications that you're looking at if you're buying a duplexer. You want there to be as little loss as possible, but you want there to be as much isolation as possible.
And so maybe you're going to talk about it, but this is where offsets come into play, right? Repeater offsets?
Yes. So I actually put my notes on the wrong slide, but I'll go back to that. So offsets. So when you program an offset in your radio, you're listening on one frequency, but when you press the transmit, it then transmits on another frequency. So that's what the offset is. It's 2 different frequencies. On 2 meters, it's 600 kilohertz.
Mm-hmm.
I think that's the same over there. On 70 centimeters, it's 5 megahertz. So the actual physical split between the 2 frequencies is a lot more. 6 meters, I think over there you have 2. It's 500 kilohertz and 1 megahertz. We use 1 megahertz here on 6 meters.
I've never worked a 6 meter repeater before.
Oh, okay.
I must be honest, but yes, go ahead.
Well, it's good fun, especially in sporadic E season.
I bet.
6 meters, but the real good one is 10 meters. 10 meters, it has 100 kilohertz offset. Or split. Okay. So that's very, very small. So obviously as you go down in frequency, the duplexes get bigger. But if you get to 10 meters, that's quite a large duplexer, because these are usually, I think they're about a quarter wave long, mm-hmm. give or take. So you can imagine on 10 meters, 2.5 meter duplexes sitting in a site.
Oh, so they're that tall? They're like taller than you are tall?
Well, they can be.
Wow.
I've seen a photo of one. I should have put it in the slides. I didn't think about it. But generally on 10 meters, we run you run 2 physically separate sites, and you link them together over a low power UHF link. So you have transmit a few kilometers away and receive to get that isolation. So, but wow. that's where splits come in anyway.
So what's actually in a duplexer? Like what's inside of them?
So you can see. In that diagram, there's the bottom diagram is a. It's a bit of a.
It's like a slice.
Yeah, it is. It is a bit of a slice. So there's coupling loops. So what they do is the energy is coupled from the input and the output port, and in the middle you've got the tuning rod, which then tunes the frequency for the pass section of the duplexer. So that's the frequency that you want to pass.
Oh, hey, Lee Harrell, thank you, buddy. Lee, you passed too? Lee Harrell passed his general today. Thank you so much. Very good. Get on HF, absolutely. Sorry about that, Hayden.
HF, hey, I still remember the first time when I passed my license, and it was fun. It was like, let's get ready, let's get on the radio.
Absolutely. And then you come home and your antenna's not up, and you gotta build it. Where's my power supply? I didn't buy a power supply. Okay, where's the battery?
Yeah.
Yep.
Or you sit there and you go, what's going to be my first radio?
That too. Yeah.
So coupling loops. So you can. You can't really see it on. So in the photo above, you can see the.
You're talking about
right
these
in the
little circle-y things.
Yeah. So they're
these guys.
Yeah. So they're the coupling loops, but in the photo above, where the actual photo. So where you had the mouse just there. That's the tuning rod for the pass section of the filter. So what that'll do is that'll tune the filter for the frequency that you want to pass. Now you can't quite see it, but there's a little capacitor next to where the coupling loops are, or where they go in, and what that capacitor does is tuning that, then choose the notch. So you want to pass the frequency that you want to on, say, the receive side, or the transmit side.
Right.
And then you want to do the opposite with the notch. You want to notch it out. So that's where that sweep comes in. You can see our pass frequency 600 kilohertz lower down is pretty much no loss at 0 dB. But then there's that notch you can see in the bottom diagram, the reject frequency rather.
Oh, right here.
Yeah, so you can see that dip.
Yep.
And that's basically what we're tuning for. So the two lines there indicate the receiver's transmit and receive frequencies.
Got it. So are these two sides then? One side's for the input and the other side's for the output?
Yep, and then they get joined at the end.
Oh, I see, right here where the coax.
Yep.
So okay, so I just noticed this while looking at this. What's the tape for? I just saw the tape. Is that important?
I actually don't know what the tape's for.
Okay. I'm like, are those tuning tape flags or something?
No, I'm trying to remember what the tape's for. I can't even remember. They might have come out of maybe an commercial site, and they were just left on there and not taken off for the photo. That might have been the reason why the tape was on there.
So, I mean, ballpark it for me. What do these cost? These duplexers? So we're looking at, this is a 70 centimeters duplexer.
No, that's a 2 meter one.
2 meter. How much what do they run?
So in America, there's a company called Telewave, which they do probably the best duplexers that I've seen. Mm-hmm. They're probably about $2,500 for a decent duplexer. That one there was, I think, a modified one though. So It was modified from about 70 megahertz to 144 megahertz.
Okay.
So you can build your own. I didn't put another photo in, but I've built one on 6 meters using LDF 750 Heliax, the really, really thick stuff.
Okay.
So, yeah, that's about roughly what the cost is.
And that's like retail price, I'm assuming. Used is always an option kind of thing?
Yeah. I just noticed a question in the chat too, from Sean Bale's question.
Oh, good. I was just going to ask you that. Perfect.
Yeah, is the duplexer worth it? Why not just use 2 antennas? You can use 2 antennas. So to get the isolation that you require between the two frequencies, as a general rule of thumb on 2 meters, it should be 100 dB or more. So the difference between transmit and receive should be 100 dB down. That's not always possible if you're running 2 antennas. So if you put on the same site, you can get more isolation by having the antennas vertically than horizontally, but you may not physically have the space on the site. So obviously it costs money to be on a site on a tower. Right. You may not physically have the tower height or the space on the site. So that's why we use duplexes in that situation. And
that's just because you can't feasibly run a second antenna.
Yeah, because obviously space, cost, whatever the case is.
Right, and again, we're talking about mountaintops in most cases, right? And you're already in a contested space. There may only be one structure, footprint to put the equipment in, right?
Yeah, so a lot of my sites are the same. I've only got one specific location for my antenna to go, and you can't really deviate from that. And that's the thing with when, as hams, we don't have the freedom that commercial operators do.
Sure.
So they have the money, they can go and put up basically whatever they want as long as they've got the money, but we don't. So we've got to be very friendly with them people, and also show them what the potential use is. So like ham radio repeaters are very good in emergency situations particularly.
Yeah.
So that's as long as we can show them that, then usually we can get access to these sites and space that usually is only reserved for those who are doing it commercially, or so for public emergency responders and things.
Would you say that's kind of how we piggyback, or at least in Australia, I'm assuming we do in the States too, how we piggyback to get some of this access is, emergency communication in some cases, to be able to like, hey, I only need a 4-foot space cube to put something in or whatever, or a rack of, some kind of vertical rack with a couple blades in it. And I just need one antenna and I'll make it work kind of thing, right? Is that kind of how it goes?
Yeah, essentially that's how it goes. You may throw in the odd thing that it's we can deliver community-based communications. So here, where I am locally, we do a lot of there's a lot of horse rides that are require communications between
like
the
long
start
distance?
and the finish.
Like yep.
so between the start and the finish, so we can use the ham repeaters to coordinate those particular events, things like that. So, but yeah, essentially that's what we do.
Same thing out here. All of our hiking trails that go up and down the coastal trails and the PCT in California, we've got repeaters all along there. And then all the fire roads, all the mountains that catch on fire and burn everything up in California, lots of repeaters. Those things burn down constantly, and then they get rebuilt from a lot of times donations or whatnot to make it happen.
Well, see, we have the same thing. We have bushfires here in Australia as well, and it's a big thing that sometimes we lose our repeater sites because they're in the way of the bushfire. Mm-hmm. One thing you did mention too about being there for those that are remote and don't have, say, mobile phone access. I know that there was a local ham that he was on a quad bike and he was riding out in the I can't remember where he was, but he was in range of the repeater and he had APRS turned on as well.
Yep. On
his handheld. And he had an accident, or someone had an accident.
It wasn't him. I believe it was somebody else. But yeah, keep going.
Yeah, and he used the radio through the repeater to call back. So in that case, it was very handy because that could have been an emergency situation, and was able to call someone who was able to notify the emergency responders.
I don't want to slide back, but I do want to go back for a second to this first slide. So again, if you have a mountain here, and then there's another mountain here, and another mountain here, and this is your city, you're not going to reach person over here necessarily with a mobile, right? And so you need something to broker this communication over the top, and that's why, particularly when you start getting real far out, there's no cell towers. And even if you got up on a mountain over here, you could still be blocked by another mountain if you were trying to do simplex, or it's just a handy-talkie, and we talked about that a couple weeks ago. You're not going to be able to power over pretty much to get that simplex comm. So repeaters are vital when you're trying to cover lots of distance.
And sometimes we'll have to link repeaters as well to extend that coverage out. So we talk about that a little bit further in the slides. But
yeah, we do.
One thing I did want to cover before we go off this one is, so when if you've ever stood at a high-powered communication site, whether that be on top of a building or near a mobile phone tower or something like that, I noticed. Where's a good example? What's the mountain that has the Hollywood sign on it?
Yeah, I was gonna say, come to Southern California. Every mountaintop has a repeater, a commercial repeater and emergency all on top of it, and everything buzzes.
Now, if you stand on top with your handheld and you try to use it, usually you can't hear anything, or it's very noisy.
Yep.
What we call that is desensitization, desense of the receiver. So on a repeater, you don't want that because then you can't hear the users. They can hear you fine, but you can't hear them. So the second thing that the duplexer does is isolate the receiver from those other transmitters to try and hear your signal. So that's very, very important, because if the repeater can't hear you, then what's the use of it?
Yep. And Mount Hollywood, they said, is Wicked Perfect says that's Mountain Lee. With that said, Lee. The Hollywood side is on a pretty low mountain. We've got some really high mountains with some pretty powerful stuff on it. So, Southern California is kind of like a mecca for VHF, UHF radio, at least local comm type stuff.
Yeah.
Want to go to the next slide? Or are we?
Yeah, sure.
All right. That was a good one. I love that, talking about duplexers.
It can get very complicated.
Oh yeah.
It's fairly simple. Just thinking about it, the way that it works, it's just signal in, signal out, and that's it. Mm-hmm. So feed line, the photo there, I use Heliax, or I'm not exactly sure. I think you refer to it as Heliax, hardline.
Hardline, Heliax, yep.
So it's got a solid center conductor, which is copper on the inner and the outer. I don't use RG58 or 213 or LMR type cable. The reason for that is because it's too lossy. So over longer runs, especially on UHF, RG58, there's a lot of loss. Even LMR 400, there's a lot of loss, because we're talking, some repeaters you could have, say, 50 what's 50 meters? 150 feet or long cable.
Hauled to the antenna?
Yeah,
Oh, gotcha.
from the shed to the antenna.
Yeah.
So this cable has a lower loss. Obviously, you can get cable that's got even lower loss, but generally, this is the cable that I use.
So your choices there are primarily low losses. It's not necessarily its ability to stand up to the weather. I'm assuming most cables do okay. LMR, for example, is great in the weather, but you're aiming for low losses because you're working VHF, UHF type stuff.
Low losses, and as you say, it can all stand up to the weather. UV
Yep.
is a big thing here. So cable does degrade if it's not UV stabilized. Same too. I didn't even add it in here, but it made me think of it. The cable ties are important. So the ties that tie it to the rack, if they're not UV stable after a couple of years of exposure, they'll just snap off.
So if you guys didn't know that, that's a pro tip, because that is a thing. If no one's told you, every ham's going to go through that. They're going to zip size something up and go, well, that's forever, and they're going to come back in a year, 6 months, and it's done.
And the worst thing is you can tell those that haven't used the correct zip ties, because you look at the tower and there'll be cables flapping in the wind that used to be tied to the tower. So, but the other primary reason that I don't use those other cables is some of them have dissimilar metal. What do you call it? Some of the LMR cable,
the electrolysis effect of dissimilar metal types. Yeah.
So even though the cable effectively shouldn't move, if you plug in an LMR piece of cable into a repeater which is transmitting and receiving at the same time, and you flex it, then you hear the crackle. I don't know if you've ever used a repeater and you've heard someone crackling. They're noise free into the repeater, but they've got noise on them. The issue is either the antenna's moving in the wind, or the cable's not right. So that's another reason why I don't use the LMR type cable. So yeah, but primarily loss. It's not like you've got the antenna in a mobile rig, which is only a couple of feet. You've got several hundred, sometimes hundreds of feet to cover. So
you didn't mention it here, but I'll ask you, what connector types do you use?
N connectors. Type. Generally, everything is N unless the system has. So, like my receivers have BNC on the back of them. So then I have an N from the duplexer, an N patch to a BNC on the back. But yeah, primarily N connectors for everything.
And to clarify that a bit, N is for low loss HF and higher frequencies, right? Is that generally the? So while you can use it in HF, it's not as important. Right.
No, that's right. For HF, RG58213 with PL259s are fine. BNCs, they're good for on the handhelds. Sometimes some mobile rigs as well. But yeah, N connectors for this type of stuff.
Well, Larry asked a question. We've got a lot of questions that we're going to ask towards the end, but he asked a question that's immediately important. What do you recommend for lightning protection?
Lightning is a very interesting topic and can almost have a live stream of its own.
Probably.
Where I live, we don't have a lot of lightning, so it's not too much of a problem. But generally, lightning arresters that can be installed one or two places. Generally, they're installed on the bulkhead of the input to the
shed.
The shed.
Yeah.
So you can see there, I don't have the lightning protection there. Actually, it's up on the tower.
Oh, man. We got a non-spec installation here. No lightning protector. Shut it down.
Don't look at it. And, of course, obviously, a good earth somewhere.
Right.
The earthing at that particular site's not that good because it's up on a physical rock and you can't easily put an earth stake in.
Yeah, that's good. Yeah.
There is an earth stake in, but it's not the best. But I have never had a direct lightning strike yet, so we'll see what happens when I have the first one. But,
so is that are you above the tree line? Is that why it's on a rock, or is it just the build-up?
Yeah. No. So that you can't. I should have given you some more photos, but that one there is actually on the edge of a cliff. It's a big rock. The height of the mountain it is on is 3,000 feet.
Okay.
Or 1,000 meters, and it's basically a sheer cliff, and it's built up on top of a rock. So
interesting. Okay. Yeah, I was curious of how tall some of your mountains are out out there? What would you say is your tallest local mountain?
Tallest local mountain is 4,100 feet, so a little over 1,200 or nearly 1,300 meters high.
That's pretty good.
Yeah, in comparison, I suppose, with Southern California, it's probably not. You've probably got sort of, probably, I don't know,
easily
5,000 foot mountains or something.
Oh
yeah,
no, 8,000. Yeah,
yeah.
7,000. Yeah, easy. And that's the local stuff. That's like my backyard mountains, not my destination mountains. Because we got Mount Wilson, which is huge.
Yeah, we still get the same. We get snow-covered mountains in winter as well. So it's still an issue with weather getting to the top of those. But that's a further slide, of course.
Yeah, absolutely. Yeah, you do have weather.
Mm.
All right.
We have a lot of wind. We've had a lot of wind the last few days.
Go ahead, sorry.
Wind is a killer.
Oh, well, tell us more about that, because we're in a thing that kills... wind kills antennas, and people were asking in the chat to talk about the antennas, so they were already very excited about this.
So these are two of the antennas that I use. So on the left, you can see that there's some dipoles. There's three dipoles there. The bottom left one's actually a VHF one. It's a little bit further away, so it looks almost the same size as the two UHF ones, which are on the mast.
This one down here, this lower left?
Yeah, so that's a VHF dipole.
Okay.
And the other one is a collinear or a vertical. Those are the your eagle-eyed viewers would probably notice what model antenna that is. We might see if someone can guess it. See if someone can guess what model antenna that is.
These would be affectionately ground planes in the States, is what we call them. But yeah, collinear too. Yeah.
Yep.
I'm pointing at the little prong sticking off of it, so somebody may know what that is.
Someone guessed Comet. That's not. Yes, Diamond. There we go. We've got the first one.
All the brands have them. Comet, MFJ, Diamond. MFJ has one. The one that's on my roof is a 17-footer version of that, basically. So, yeah.
Basically, they're just phased 5/8 antennas just stacked, and the longer you go, the higher the gain. So antennas are vertically polarized, so not horizontal generally. And these are the two main types of antennas that you'll find. So the ground plane verticals, collinears, and the folded dipoles, both of which have advantages and disadvantages. So because the repeater transmits and receives on them at the same time, they have to be durable, so they can't move physically in the wind, because we will talk about that under challenges later. They've got to be high performance, durable, and they have to be efficient, because usually they're out in the weather, the wind, the snow, the ice, and they can't break, because otherwise we have to keep constantly going to fix them all the time.
Yeah.
So one thing I will mention about the diamond antenna, whilst I have that up on a tower and I am using it, I don't recommend it as an antenna because of a few reasons, but they do work well if you do modify them for repeater use.
So what is that exactly? What's the problem?
So the diamond antennas, as they come from the factory, they have an aluminum.
It works. It plays.
Aluminium.
Yep.
Aluminium base that you slide the antenna into.
Yeah. Yep.
One screw. You probably know that. Over time, with the wind, the screw will come loose and the antenna will move in the base. So because you've got the intermittent metal-to-metal contact, when you're transmitting and receiving at the same time, you'll hear crackle and pops as it moves in the wind. So you can see in that photo, we've actually replaced that with a big nylon
right here.
Insulated mounting tube.
Yeah, right here.
And because the antenna's DC grounded, we actually don't need to bolt it directly to the tower. It doesn't have to have a metal a metal mounting bracket. It can use a plastic one.
Yep.
And that there has solved that problem, and the antenna moves in the wind and it doesn't make those noises. But the key point is that any antenna that you do use has to be of high quality, and it also has to last in the environment that you put it in. Same as if you're doing it at home. If you lived on top of a mountain, you wouldn't put an antenna up that's going to fall down at the next winter.
Sure, but you're maximizing the weather effect, right? Because you're already high up and you're at a peak, so you're getting all that cool wind slamming over the top of you. Do you like the folded dipoles for that reason, or I mean, what's the disadvantage or advantage of a folded dipole in this case?
So the advantages of a folded dipole is that one of the things you can do is you can control the pattern of them. So generally the vertical antenna as built's omnidirectional.
Oh,
With folded dipoles, depending on how far you stack them vertically or horizontally, you can control patterns of how you want the coverage of the repeater. So in this instance, behind the repeater, or behind where the folded dipole is the opposite way that it's pointing, there aren't that many users. I wanted to concentrate on the city below, so that's why they're pointing in that direction, and that's the pattern that they have. So you can control the pattern with folded dipoles. They're also very good in snow and ice and wind because they're a lot smaller and they don't take up as much physical room. So when ice builds up on them and wind blows, there's not as much ice loading.
Yep.
Or wind loading, sorry.
So if we're looking at this picture, like this one down here, you got the cityscape down below. When you're using that Omni, do you keep it vertical or do you pitch it a little bit?
That's a very good question. So with verticals, when you have them straight up, then they have the radiation pattern is at the horizon or as close to the horizon as possible.
Right.
In that situation there, because of the majority of the users are low down.
Right, down here in this area, yeah.
If you pitch the vertical antenna down, that will work. But then in the opposite direction, most of your signal is going into space. So that's a bit of a waste.
Yep.
With folded dipoles, between the two folded dipoles, there's actually a piece of coax which affects the phase between them. And if you make one, when the signal comes up the coax, if you make it go to one dipole before the other, just a fraction of with the phasing harness, if you change the length, you can make the signal arrive from one to the other, and that electrically then tilts the signal down. So rather than physically, it will electrically tilt it on both planes. So I'm trying to think of a simple way to explain that because it is very complicated.
Is it that you're making one part of it longer and the other shorter, kind of? Or you're moving more of it to the top in some way? It's the way that you line it?
It's the phase. So the phase of one antenna lags the other, but only by a little bit.
Oh, okay. I gotcha. So this guy is going to have a longer coupler piece than the other one, or vice versa.
Yeah. So essentially, the signal is going to get to one of them quicker, but only by a very, very, very small, minute time.
Right.
Than
tiny.
The other.
Yeah.
Yep. And then what that'll do is that will then shift the pattern down, and you can get negative below the horizon radiation patterns to cover down into the cities. Now you might think, but then won't that mean that distant stations will be affected? Well, if you look at an antenna that's sitting on or a radiation pattern, there's still quite a bit that gets radiated high up.
Right.
That doesn't really go anywhere. So that then effectively also gets tilted down. So you still get your coverage out to the horizon.
Very good. So I think the answer, we already covered this, but Zach asked, do you build the antennas to a frequency or just buy one for a whole band, like off the shelf? It sounds like you're running the Comet, and that's just off the shelf, right?
Yeah, so the Diamond Comet, whatever it is, is off the shelf and it covers that band. The folded dipoles were built specifically for that frequency. That's actually on that site now. I don't run those antennas anymore. I did swap it out to a vertical, which is also built for that frequency. But generally, you do want to pick, or you do want if you're building an antenna, you can tune it for the frequency that you want. So
and by tuning, we're talking specifically cut for that frequency. The space you're going to work in, so that's what you cut to.
Yeah, we're talking best SWR, highest return loss, that sort of thing.
Yeah, very good. Okay, great. All right.
Right, linking repeaters. So you spoke about too in that previous slide where if you've got lots and lots of mountains and you put repeaters on them so that they can, to talk from one person from one valley and you want to talk to another person on a far distant valley, you need to link repeaters together. So there's a couple of ways that you can do it. You can do it over RF, which is the conventional way of doing things. So you have generally a separate radio that's attached to the main repeater.
Would you call that the real radio way of doing it?
That is the real radio way of doing it, I guess.
So you don't get complaints.
There's
This is real. This is real ham radio. We're using RF linking.
Hey, there's still many links out there that are still done with RF. So but there's many that are doing IP, of course, now, which can be more efficient. But obviously, it relies on the internet. The internet can go down.
Yep.
So, whereas RF generally doesn't go down as long as you've got battery backups and things like that and power.
Are you doing RF linking?
I am doing RF linking, yes.
Oh, that's awesome. Okay, cool.
Only on some repeater sites. The majority of it is IP. Yep. So we have a separate link radio, which is attached to a repeater. And usually that's either on simplex. So you can see in that diagram, there's two 440 meg link receivers, and they're both on simplex, on one simplex frequency. And they both talk to one another and link the two repeaters together with the various audios in and out.
So it's basically cross-link repeating.
Pretty much. Yep.
Yeah, you have two cross-link repeating stations that go into the repeater itself, if you will.
So repeater 1 on the left-hand side might be a 2-meter repeater linked into a 440 link, and then on the right-hand side might be another 2-meter repeater with a 440 link.
Got it.
So a variation on that is repeater 1 might be a 2-meter repeater, and it might have a 440 link, but the other end, repeater 2, is a 440 repeater, and you don't need that link transceiver. So you can just link directly into it, and we call that in-band linking. So,
any issues with that? Does it affect the offset or anything like that, or does it matter?
No. So generally, all you really have is the link transceiver is just set up on the other repeater's frequency, as if you were talking to it directly.
Right.
The only other issue that we come across sometimes might be fade. Maybe the RF path is not the best. You might not be able to see the other repeater site. So that's where IP can sometimes take over. So I've got IP linking using All-Star. So All-Star in it is basically a repeater controller. So as well as a bit like All-Star operates like Echolink and IRLP for linking as well.
What do you like more, All-Star or Echolink?
I like All-Star because All-Star allows you to do a whole range of things, whereas Echolink's very limited. So All-Star, you can change the quality of the audio you want. You can change all sorts of things, whereas, you're fairly locked down with Echolink.
Every repeater owner I've talked to has said they like All-Star more than Echolink.
Yeah, Echolink's fine for setting up sort of quick links for events and using your computer to talk to other people through RF links and things. But generally for this sort of thing, I prefer All-Star. So, so All-Star, it's either directly connected to the repeater again, or it's connected to a node radio that will then connect to the repeater. There's also voting, which we won't go too deep into it, but you can have multiple receivers. We spoke earlier about that. Someone with a handheld listening to a 100-watt repeater and they're using 5 watts. Well, if you put a voted receiver, you can have multiple receivers. If you put them closer to the users, then it means that they can, the repeater will choose which receiver has the strongest signal from the user and will put that to the transmitter. So that's the simple way of voting, I suppose.
That's a video on its own, basically, that how to work that out, because you need a specific controller to do all that. That's on my channel I did do a live stream which I did talk about the voting system that I run. So cool.
If anyone's interested in it, they can check it out. By
the way, if you're coming in a little bit late, make sure you follow Ham Radio DX, guys. Link is in the description. Go check him out and hit the subscribe button. Follow him.
But speaking of voting too, that's exactly how the emergency responders operate with their radios. When they've got handhelds in buildings, they might have a receiver sitting in the building, so they use that the most. So DMR, D-Star, that's all over IP. They're linked via the internet. Same thing as well.
Yep. All right.
Cool.
So these are a lot of questions that we already had, or Hayden already has answers for. We got a ton of questions that I think we're going to cover right now. So let's do it.
So some of the challenges, obtaining isolation. So we spoke about descents. That's when the transmit wipes out the receiver. Running 2 antennas rather than one. We did speak about that. So one of the challenges with getting that isolation, as I think we also covered, is the duplexes. So sometimes you can't, on 10 meters, for instance, you can't run a duplexer because of the physical size of them. So you have to have 2 separate sites with 2 separate antennas split apart. There's no sort of hard and fast rule about how much isolation you need. You need enough plus a little bit more in case things change in the environment. So, but as a general rule of thumb, I say that on 2 meters, because of that small offset, that 600 kilohertz offset, you generally require about 100 dB of isolation between the transmitter and receiver.
Okay.
And on 70 centimeters, you probably get away with a little bit less, maybe 80 dB, 90 dB, something like that. One of the other challenges is power. So if we don't have access to power on a remote site, so using solar, wind power, you need to make sure you have enough batteries. Sometimes we have long winters as well, so that reduces the amount of sun that we get. Here in Australia, where I am,
I always forget that fact that, you know, you actually have a situation where you're going to get a lot of sun, so you're going to be no problems. You can run with less, but then flip that, and now all of a sudden you're dealing with like a deficit of power.
Yeah, because where I am, in summer we get the highest amount of daylight hours in the country, but then in the winter we get the complete opposite. So in the middle of winter is when your repeater is really going to struggle because it's not receiving enough sun. The other thing to note too is that the amount of time that a repeater transmits is fairly low in comparison to how long it's always running. So if you think about, say, a repeater draws 10 amps and that runs that 10 amps for an hour, that's going to take 10 amps out of the battery. But if it is using 1 amp standby for the other 23 hours of the day, that's 23 amps as well that it's going to take out. So it's not just sort of how much power you're consuming while it's transmitting, it's how much power you're consuming all the time that you've got to think about as well when you plan a solar system.
Interesting. We literally have a fire alarm going off in my house right now. Can you hear it? Can you hear it?
Yeah, I can hear that.
I hope my wife is home, so...
But as we spoke before,
okay, it's over. Jeez, God, I can't do a stream without something happening.
I was going to say, you mentioned about before the stream your computer getting hot. I was a bit worried there for
yeah. Hey, are you looking around? Are your feet on fire? Because I'm literally got my foot on the stream computer, basically.
What's that smoke in the background? Yeah, so, and obviously we spoke about weather, so robust antennas, cable, weatherproofing.
Sorry about that. Sorry about the beeping in the background, guys. So, did we cover that? You got the...
Yeah, we covered that.
Okay, sorry.
And just before you go to the next slide, go back a slide. That antenna, you can see ice and wind is a bad combination. So that vertical antenna...
is gone.
It's gone. Got snapped off. So one of the other challenges too, of course, is making sure that everything you know how I spoke about that antenna sitting in a base and moving, and you get the popping and the crackling. It's not just the antennas that you've got to also concentrate on. It's washers, it's nuts, it's bolts, it's fences, chains, it's signs on a tower like that one. It's anything within the RF field of the antenna that could potentially be lit up with RF energy.
Sure.
If there's something loose, you'll get that crackling and that popping. So
I've got a ground. So you're saying you got a RF ground your caution radio frequency field sign so that it doesn't cause a problem?
That's right. That's right. And as you can see, there's a couple of zip ties there.
It's just floating. It's just floating.
It is just float. That's not there anymore. Needless to say, that's not there anymore. So the other challenge is site access, tower access. We're hams. It's difficult to get this sort of thing with the budgets that we run with, but it is possible. Riggers A lot of towers, very high. We need professional riggers to put our antennas up.
Yep.
Heavy duty antenna mounts for the towers because we don't want to put up something that's going to look unprofessional. And also the rent and the cost of doing this, because we have to pay ongoing rent and also maintenance costs as well.
What does that run you? Rent and power and all that stuff. What does that cost you generally? Do you know? I mean, is that a ballpark thing you can give?
Power costs. It's a bit hard to gauge my power costs because a couple of my sites, the power is actually donated, I suppose is a good way to say it, because it's at a site where there's high power TV transmitters. So this little repeater in the corner, they don't really notice it because it's such a low power.
Oh, sure, yeah. So you just like, hey, bro, can I plug this in?
Yeah, and they're just like, yeah, sure. There's
all right.
No cost for the power. But yeah, a couple of other sites, it probably ranges from maybe a few $100s a year to it could be a few $1,000s depending on whatever they really want to charge you, I suppose.
I guess, yeah, depending if they can fit something commercial in there and make some more money out of it, right?
That's exactly right. Yep.
Yeah. Okay, questions. Were you ready for that slide, by the way? I just jumped ahead on you.
Yeah. No, that's fine. Actually, interesting in that you can see there's two VHF cavity filters in the bottom there, so duplexer cavity filter. Those ones are just by themselves, and they're for the one on the far left is for APRS, for VHF APRS.
Okay.
So all that's doing is basically isolating the APRS frequency from all those high power transmitters, the TV transmitters that are on that site. And the one on the right, I think, is just a spare that's sitting there.
Oh, cool.
Yeah.
So we got a ton of questions. Matt asked a couple of really good ones. So what are things that you were surprised to learn about installing, operating, maintaining repeaters that an average user might not know? Anything that is especially irritating or fun?
One of the surprising things was how difficult it is to get a working system on a communication site where you don't have to go back every week and fix it. If there's anything that can go wrong, it will go wrong. But I just think generally over time you just get used to the things that you've done in the past that you've made mistakes on, and you learn from them. So like we mentioned about the zip ties, just using the correct ones so that they don't snap off after they've had a bit of sun on them. So it's just things like that you do gradually learn over time. What was the second part of the question that he asked about?
Anything especially irritating or fun? But I was going to ask, like, how often are you going out to the repeater sites? Like, how much time do you spend futzing with repeaters?
Not so much these days, but
sounds like in the beginning though there was a ramp up period, if you will.
Oh, definitely. So in the beginning, sometimes we'd spend hours there trying to fix a problem that we just couldn't work out what was going on. But now you get a good idea that when something breaks, you get a good idea of what it is, and you can pack accordingly. So what tools you'll need, what bits and pieces to fix the problem. And then generally 9 times out of 10 now when you arrive at the repeater site, it's something different and you just got no idea what's wrong.
Do you, this just came to me, is there a top 5 tools that you have in the tool bag in the back of your truck that you drive out when you're going to go work on a repeater? The things that you're going to have in your pocket you must have, or you're not even going to be able to work?
Yep. Top 5 tools, side cutters.
Okay.
Shifter spanner.
Okay. Now you got me up. What's a shifter spanner?
Shifter.
I know what a spanner is. Spanner's a wrench, but what's a shifter?
We call it a shifter. It's an adjustable spanner. It's an
adjustable
wrench.
Oh, like a crescent wrench. Got it. Okay.
Yeah, adjustable wrench.
Got it. Like it.
What was that? 2.
2.
Probably third one would be electrical tape. But
sure. Yep.
Electrical tape, whenever there's any outside connections, don't use electrical tape. to tape them up.
Yep.
Because electrical tape's only good for sealing up, for sealing in water. So water will get into electrical tape.
Do you use that self-annealing tape when you're outside?
Yeah, the fusing. We call it self-amalgamating, but self-fusing tape. And then
I think that's actually the right term, but it's this guy, this stuff.
Yeah, that's it. Yep.
Oh no, no, wrong one. But yes, like that.
It looks like that.
Yep.
And then what we go
that
over
was
the top
3?
of that is. Sorry?
No, go ahead. Sorry.
Oh, and over the top of that tape, the fusing tape, we do put electrical tape because even though it doesn't seal the water out, it seals the UV out because the fusing tape's generally not UV stable.
Oh, good point. Yeah, good point. Yep. Okay, so that was 3.
Number four, multimeter.
Sure.
Definitely bring the voltmeter, the amp meter.
You got a Harbor Freight out in Australia?
Sorry?
Do you have Harbor Freight in Australia?
Freight. No.
It's a store.
Harbor Freight?
It's a really, really cheap store where you buy really, really bad tools. And I was going to make a joke about buying a Harbor Freight multimeter and taking that with you. Don't do that.
No.
What's the multimeter that you have?
I've got a Fluke.
Multimeter. Okay. Got it.
Yep. Can't remember the model number, but I've had it for years, and it'll keep going for years, I think. And number 5 is probably my test set spectrum analyzer.
Yeah, so you went from you ramped up really nicely. Like you could get started really cheaply, and then just went Fluke and a signal generator.
Signal generator. Funny story about my signal generator test set. It's a HP 8924C.
Oh, okay.
It weighs 30 kilos.
Oh, my God.
And I bought it from Israel.
Oh, my God.
I bought it off eBay, and it was $700 and $300 in freight. They freighted it out through DHL on a Thursday night, and it arrived in Australia at my doorstep on Monday morning.
Wow.
And I couldn't believe it. I looked at it. I thought, "There's no way that this thing's going to arrive in one piece."
That's insane.
It's still going, and it weighs 30 kilos, and I lug it around everywhere. If anyone wants to buy me the lightweight version, they can.
That's crazy.
Yeah, but yeah, they're the top 5 tools.
Okay. Let's see. This one might be a little open-ended. Understanding that there are variables, can you describe in general what to expect in terms of funding? The funding it takes, like the initial install and then recurring costs. I know we didn't go into a lot of this, but you just ballpark it's probably going to be acceptable in this case.
Yeah, so a lot of repeaters are set up by clubs because clubs can generate the revenue to maintain and install repeaters.
Right.
A couple of mine are funded by clubs. A couple of them are ones that I've just put up myself. So, and the ones that I've put up myself have been made from gear that has been donated. So not necessarily me go out and buy the gear. It's been donated or built by myself. So again, that's the other good thing about ham radio is that you can repurpose old gear for our purposes and just, build a system up from scratch basically. So probably, I guess, if you're thinking of a ballpark figure and you were to go out and buy, say, the Yaesu DMR or the Yaesu DMR units straight off the shelf with a $2,500 duplexer, the feed line brand new antennas, it could cost you upwards of probably $5,000-$6,000.
And then recurring costs, that's just going to add up over time. Your time, right?
Fuel, gas, as you go to the site, depending on how far you have to travel, and my time. Yep.
Yeah.
Yep.
Indeed.
Which
Don, right? You could be making YouTube videos.
Yeah.
Or you need to make more videos of going out to the repeater sites, maybe.
I think I've made one.
Yeah, you could probably just do put together a compilation of the best of crazy stuff you've seen. Just weird, cable fails, go around oh my God, who wired this thing? And just, or every time you see a UV tie wrap that's broken, take a picture of it and then just stitch them all together.
Well, I didn't see a UV tie wrap, but I did see one of those dipoles hanging in the wind by its coax. So it obviously fell off the bracket.
So that doesn't have the propagation where they want it.
No. Very limited coverage.
Dawn N5 SKT asked a question, which is going to probably lead to another question, but we are running out of time. This went really fast. Hayden, this has been awesome, by the way. Question.
Yeah, it's been great. Thanks, Josh.
Why don't some repeater operators act to control bad operators using their repeaters? I have a ton of thoughts on this, but I'll let you go ahead. Do you have to deal with a lot of lids in Australia? Do you have to deal with that as much as we do?
Occasionally. Generally, it's very difficult to police.
Sure. Yeah.
As a repeater owner, and sometimes it can get a bit frustrating because someone will come to you with a complaint and say, "We've got this person interfering on your repeater. Can you fix it?" There's not a lot that you can really do about it. You could
other than pull the plug. What are you going to
do? Turn the repeater off. That's about all that you can really do, and you can't. I don't know about in America, but in Australia, you can't then put a code on it and only give the code out to so many people. It's there for everyone to use. So in the end, if someone's interfering with the repeater, it's easy to just ignore it.
Yep.
Because people, if you ignore them, then they'll stop doing it eventually.
Well, we have the same policy out here, aside from the 435. So aside from maybe changing the offset, I was thinking you could change, not the offset, the PL tone. You could change the PL tone, but then everybody would be, in the dark, and it's easy enough to figure that out. Most repeaters or radios, you can just click it and search for it. So the best thing to do is not engage with the trolls, just like you're not supposed to engage with trolls in your YouTube comments or anything else. Don't do it. There are, outlaw repeaters, particularly here in Southern California, and people gravitate towards that, and they live there, and the FCC even says, if they don't exit that area and they stay there, then we're not really going to mess with them. That's in the States thing. Yeah.
It's not too much of a problem, but occasionally you do get that pop up, and but 95% or even more, 99% of the operators are fine. So
I would probably agree with that too. So I think this is going to be the last question. And guys, we're going to be going to Discord after this, so make sure you come join us for the Discord live after chat. I don't know what Hayden's doing, but he's got an active invite to come join us.
Hey, I'm here. So it's 11 a.m. in the morning, in case anyone was wondering too. So
yeah. So you got all day, right? Okay.
I got all day.
Have you ever done Discord before?
No, so you'll have to
talk
me through
it. Don't hang up when we end here, and I'll get you on it. So the last question, actually, Ethan has a question I'll save for the very, very last. So operating a repeater sounds like a lot of work, and specifically a lot of maintenance. I imagine it's a thankless venture. Why do it?
Well, it sometimes can be a thankless venture. I won't say that it is, because it's not just myself. There's other people that do a fantastic job. There's others that contribute to it in other ways. And, I think as a whole, if all the repeaters just disappeared overnight, people would be rather confused for starters, but then they would be, appreciative of how much work that really does go into it. The reason I do it is that I like to provide a service back to amateur radio, back to ham radio. Awesome. And that's one of the services that we provide that can be used in many different ways, not just for talking on, but for emergencies, for all sorts of things. So that's the reason why I do it, is to give back to amateur radio, basically.
It sounds a little bit like Misery Loves Company, too. Like you've got a little cadre of friends, and you're like, man, I'm going up to the mountain again. Bring your beer, and we're going to go fix this. Oh, do you ever drink beer after you're done fixing the thing on the mountaintop right there?
Only if you have a very stressful day.
But that has happened, I assume.
Yeah.
All right.
Yeah, you mentioned too, you do have a bit of a repeater team. So mine I'll build the repeater and build the technical side of things, but then I've got someone else who helps me with the hardware side. So the brackets, the outside, the antenna.
Oh, that's nice.
For attaching that. So that makes it really easy for that, because I can say, hey, I need this bracket to go on this pole and this size, and he'll come up with it like that. So
that's great. Is that a friend of yours, or is that a club thing you've worked out, kind of?
No, that's another ham in the club.
Okay.
And he's just really good with that.
So I gotta say, you make me jealous of your club. Sounds very active and involved, and you can get engaged. It's I think we started out asking this question, but you largely kind of just started involving yourself in a lot of these, or asking to be involved, right, for a lot of these builds.
Yeah, so that's what happened. And if you're interested in this sort of stuff and you're watching this stream, then go to your local club and find the repeater officer or who's in charge, and just say, hey, I want to check out how it works. Can you show me? And they'll be pretty obliging most of the time, and they'll say, look, this is how all the bits come together. Like, they're always keen to see new people involved and to even lessen the load on them. So
I love that comment. I know that we talk about horror stories in clubs a lot of time, but it sounds like, well, there are a ton of great ones out there, and from everything I've heard, they're generally very open to let people learn how things go. So man, we're looking at an hour and 15 minutes here. Hayden, this is awesome. This went way too fast. Yeah, go ahead, man. Go take the floor.
One thing that we didn't cover, because you did send some questions through to cover. I don't know if there's been any questions.
That's right. It's 11 o'clock where Hayden's at. He's got all the time in the world, so he's going to use it all. No, I'm just kidding. Go ahead.
Frequency coordination.
Oh, good. Yes, go ahead.
Yeah, we'll just cover that quickly. Yeah. So in Australia, the frequency coordination's done by the WIA, which is the ARRL equivalent, so the Wireless Institute of Australia.
Okay.
They have a technical advisory committee. So what they do is you submit the frequencies that you'd like. They look at other frequencies on the site that you're going on. They'll also check other repeaters in the area that are licensed, and they'll say, yep, or they'll give you a different frequency to use as an alternative. Mm-hmm. And then once that's been granted, it's approved by the regulator, which here in Australia is the Australian Communications and Media Authority, or in America, the FCC equivalent. So,
okay. And so that's largely just to keep people from stepping on each other.
Yeah, essentially. And frequency sort of clashing of frequencies is not that big of a deal here unless it's in the big cities, and sure. It hasn't been that big of a deal until DMR turned up and D-Star turned up on the scene, and then it was like, whoa, we've got no room anymore. So yeah, it is helpful to have that in place.
Man, is there anything else you want to say? You want to plug anything? You got anything coming up? Any upcoming videos you want to let people know about?
Ham Radio DX. Josh put a link in the description below.
Yeah, check him out.
The only video that I've got planned coming up is a review on an MFJ 1026 noise bridge enhancer unit for HF. So if you've got HF noise at home and you want to know if the MFJ will get rid of it for you, then yeah, keep an eye out for that video.
Did you just take like Chinese wall warts and plug them in next to it and see if you could kill it?
No, I've got man-made noise. Or I live in suburbia, so
okay.
There's noise everywhere.
Is like recreational marijuana a thing that you have in your country, your area?
No, that's illegal in our country.
So in California, it's kind of recreational now. So
the lights
will kill you. Will kill you. Yes, absolutely.
Well, it's not so well. The lights do kill us here because a lot of us use LED lighting now, because it's where I live is all modern houses. And that's bad too.
That can be bad too.
Is LED lighting, and I got some Chinese LED lights and put them in. They were really cheap and they worked really well, but they were horrible for noise, absolutely horrible. Yep. So I went to the hardware store and replaced them with slightly more expensive ones, and that fixed the noise issue. But you don't have a lot of control with your neighbours a lot of the time.
Sure. Well, I've got one more thing to do. Hayden and I are going to talk after the chat here and hopefully jump over to the after chat. So if you guys haven't already taken that link, go join us in the Discord. Again, it's like IRC chat, but there's also a voice component. We do chat room stuff and some voice stuff to do the end of the stream. I live stream that to Twitch, where we do some radio stuff after right now, basically. So Hayden, again, this has been awesome. We will definitely have you back and bring us some more cool information of what it's like out on the mountain building these repeaters.
Thanks, Josh. It's been great being on here, and thanks for everyone for watching as well.
Appreciate that. All right, we got to do one more thing, and then we're going to head out. So big thank you to my patrons, Chris Ebert, Carrie Blackwell, Jason Brown, Jason Siebert, David Dansero, Danny Miller, Wesley Magyar, Barbara Schrock, Will Ladd, Franklin Lewis, Brad Snyder, Dennis Dunderdale, Garrett Larson, Jonathan Franson, 86DM Dennis, the Wyoming Ham, Randall Hinsley, Evan Hartman, Dennis Mickelson, George Gaini, Andy, Kenny Miyamoto, Ron Thorson, Ken Hall, Corey Vuelta, Mr. Mode, David Mays, Devin B. Hedge, Mark Chase, Raymond Cracker, Geraldo Kelso, Rob K8BCR, Lee Harrell, Michael Kearney, Steve Barker, Mark Fields, Corey Sheldon, Brad Nadow, Stephen Hunt, Brian Nosowitz, Connor Carroll, Mike Marusin, Mike Heerly, Harald Carpenter. Sorry, that's a new one too. And guess what? We had to go to a second page. Ian Webb, Sean Bales, and Jason Barrett. Thank you for all the support, everybody. It's been a lot of fun. Very much a lot of fun. This was great. I saw the amount of slides that Hayden put out, and I'm like, we'll blow through this in 30 minutes. Man, we were like going. That was amazing. So anyway, thanks, Hayden. Please go check him out. Take the link in the description. I'm heading over to Discord. I hope you join me over there, and we'll be live streaming to Twitch as well. Take it easy, everybody. Enjoy the rest of your weekend, and have